Hello student, I am Dr. S.L. Munde, Assistant Professor Department of Mathematics, Sri RLT College of Science, Akola. With the reference of previous lecture, we have taken generalized argument principle problems and some theorems. So with this lecture, we will start our next point, that is Rouches theorem and some problems. So first we will see Rouches theorem, then we will see some problems on a Rouches theorem. Okay, so what is the statement of the Rouches theorem? There may be the question in your examination. State and prove Rouches theorem. The statement is, suppose f and g are two meromorphic functions in the neighborhood of open circle whose center A radius r with no zeros or pole on the circle, and it is given as gamma, a set z such that z mod z minus a equal to r. If zf and zg, pf and pg are number of zeros or number of poles of the function f and g inside, and gamma counted according to their multiplicity, if mod f of z plus g of z less than mod f of z plus mod g of z on curve gamma, then we have to prove that zf minus pf equal to zg minus pg. Okay, so this is the statement of the Rouches theorem. Now we will see the proof of this Rouches theorem. So what is given that? So we have given f and g are the two meromorphic function in the neighborhood of the circle whose center A radius r with no zeros or poles on the circle, and this is given as a circle. Okay, so if zf and zg, pf and pg are the number of zeros, so these are the number of zeros and these are the number of poles of the function f and g inside the circle, gamma counted according to their multiplicity. Okay, that means we have given mod f of z plus g of z less than mod f of z plus g of z. Okay, so which is the given things in your statement. Okay, now we will divide on both side g of z. Okay, so dividing g of z on both side, we will get here 1 plus g of z, that is 1 plus f of z upon g of z. So we can write 1 plus f of z upon g of z less than f of z upon g of z plus 1. Okay, so dividing on both sides by mod g of z. To prove this theorem, so let us we consider f of z upon g of z equal to lambda. Then it is clear that the lambda cannot be takes the values 0 or any positive real numbers, because in that case we get inequality. Okay, so therefore we define a function f divides g, and which is defined on a mapping on a closed circle center area radius r in c minus in interval 0 to infinity. Okay, so here f and g are the analytic functions, so therefore we can say that the ratio of f divides g is also analytic function. Okay, so log of f of g is a multiple valued function. Okay, so therefore we can restrict the domains and takes the suitable branch cut, so that log f by g becomes a single valued and analytic function. Okay, so taking log to the function, taking differentiation with respect to z to the function log f by z. So derivative of this term is 1 upon f of g into f of f by g dash. Okay, so therefore by using Cauchy's theorem, integrating on both sides, so integral of f by g dash upon f of g dz equal to 0. Okay, so this can be written as, if you take the derivative of this term and solve this, you will get these steps. Okay, so separating this term, so we will get g of z f dash of z minus f of z g dash of z upon divided by f of z into g of z. Okay, since we have f of since okay, so multiplying on both sides 1 upon 2 pi. Okay, so what we have seen here, so here we have seen by using the Cauchy's theorem. What is the Cauchy's theorem? Integration over gamma f divides g dash divided by f by g dz equal to 0. Okay, so take the derivative of this term. Okay, so this can be written as z f dash minus f g dash divided by z square into g by f. Okay, so derivative of this term can be written as this type. Okay, so this uh, f by g can be written as g by f dz. Okay, so then what is next step? Now we will separate we will separate this term. Okay, so this can be written as f of z, okay, g of z into f dash of z. Z means g of z into f dash of z minus f of z into g dash of z, we can write. Okay, dz upon f of z into g of z dz. So multiplying on both sides 1 upon 2 pi. So you will get 1 upon 2 pi integral over cos gamma f dash of z upon f of z dz equal to 1 upon 2 pi integral over gamma g dash of z upon g of z dz. Okay, so by using argument principle, we can write zf minus pf, which is equal to zg minus pg. Okay, so in this way we can prove the Rouches theorem. Okay, so this is a very simple proof of the Rouches theorem. Now we will see some problems on a Rouches theorem. So what is the first problem? Show that all the four zero of the polynomial function z to the power 4 minus 7z minus 1 lies in the disc mod z less than 2. What is the solution? Let f of z equal to z to the power 4 minus 7z minus 1. So let us we choose g of z. G of z means z to the power 4. Okay. So consider here z lies on mod z equal to 2. Okay. So and mod f of z plus g of z equal to, what is the f of z? That is z to the power 4 minus 7z to the power plus z to the power 4, and g of z is, that is z to the power 4. Okay, so this z to the power 4 and this z to the power 4 get cancelled, so only remaining term is minus 7z minus 1, and mod f of z plus g of z can be written as minus 7z minus 1. So at mod z equal to 2, so we will get 15. So similarly, mod f of z at a point mod z equal to 2, we get, that is after solving, we will putting the value of f of z from given equation, we will get 1, and g of z at z equal to 2. So putting the value of g of z at z equal to 2, so we will get 16. Okay, so here mod f of z plus g of z equal to 1 plus 16, that is 17. Okay, so therefore on mod z equal to 2, we get 15 less than 17. So therefore by Rouches theorem, mod f of z plus g of z less than mod f of z plus g of z. Okay. So therefore by using Rouches theorem, so here f and g have no poles. So therefore zf equal to zg. So therefore f and g have same number of 0 inside the mod z less than 2. But g of z has zeros of z equal to 0. So repeat it 4 times, we can say that f of z has a 4 zeros inside the circle mod z less than 2. Okay, so this is the first example on a Rouches theorem. Now we will see the second example on a Rouches theorem. Show that z to the power 4 minus 7z minus 1 has only one zeros inside the region mod z less than 1. So let us consider what is given. So we have given f of z equal to z to the power 4 minus 7z minus 1. So take g of z means that is 7z plus 1. So consider mod z equal to 1. Now we will find out the mod f of z plus g of z. So put the values of f of z and g of z and solving for z equal to 1. We will get 1. Then we will find out mod f of z at z equal to 1 plus mod g of z at z equal to 1. Putting the values of f of z and g of z and solving, we will get 15. Okay. Then by using Rouches theorem, f and g has a same number of zeros inside the mod z less than 1. But g of z equal to 7z plus 1. So it has only one zero minus 1 by 7 inside the mod z less than 1. So therefore f of z also has only one zero in the region mod z less than 1. Okay. So in this way we have show that two problems on a Rouches theorem, and I will give one example homework. Show that the function z to the power 4 minus 7z minus 1 has three zeros inside the circle inside the analysis 0 1 2. Okay, so we have already seen such types of analysis problem in previous previous unit. Okay, so previous two three before lectures. Okay, so you can easily solve this problem. Okay, so in this lecture we have seen state and prove the Rouches theorem and some problems on Rouches theorem.